welcome to PASC26. This is the highlights from the mini symposia. I'm here with Michael Erst from EPFL, so we are Switzerland, Lausanne. You organized the mini symposium Advancing Atomistic Materials Modeling with GPUs, Novel Algorithms, and Error-Controlled Methods. So Michael, can you tell us what was the mini symposium about?
Yeah, sure. So in the mini symposium, we were looking at how new ideas from mathematics in terms of analyzing algorithms and basically performance can be used to make material simulations faster and more reliable. So given that nowadays basically people run millions of these kind of simulations every day, and 30% of supercomputing resources tend to be occupied by this kind of simulations, questions about basically when do methods fail, how accurate are methods, and how accurate do they really need to be in order to get a scientifically well-defined answer are quite pressing. And so we had some people discuss ideas about errors, controlling errors, about new algorithms, and also basically how really to use modern hardware, cutting-edge HPC, in particular GPUs, in this context of improving density functional theory computation.
What are the immediate challenges that you are facing?
I think the challenges for us are really the fact that the potential chemical space of materials is quite vast, and therefore the physical and also mathematical properties of really solving these simulations is also very vast, which means that in practice people often need to tune manually parameters in order to make their simulations work. But the problem is, of course, at the level of 1 million or tens of millions of simulations, hand tuning is not an option. So basically taking ideas from analyzing these kind of problems and therefore sort of mathematically approaching this has some advantages. And then, of course, this is hand in hand with questions of hardware, with questions of actually bringing all of this to the metal and improving performance of the simulation.
But then you had this mini symposium with several discussions, probably also new ideas were brought up. What would you like to see happening? I mean, not to lose the momentum that you have created again here at the PASC conference.
Yeah, I think a big problem in this field is really that different people have very different mindsets and contexts, how they approach it. This has to do with the fact that a PhD in math works fundamentally different than a PhD in computer science or maybe physics. And therefore, they approach the problem with a very different, research agenda. And kind of combining this and making sure that people are really able to contribute in pulling along the same string in the same direction, that is very difficult. And I think to very much an open problem in this field, how, for example, software platforms can help. And we had one contribution from Quantum Espresso, a very large software community. They talked about modularization, how they try to really structure their software to make this happen. Another set of talks was from the Density Functional Toolkit, a tool that we developed with a similar kind of intention. So really bundling people. That is a challenge, and that will continue to be a challenge in the future.
So it will continue to be a challenge, but probably this is the path to follow. So to keep bringing these people together and keep discussing and keeping the discussion open, such that at a certain point maybe you will also converge.
Well, maybe not, but we will try.
So thank you very much for joining us.
Thank you very much.
See you next year, PASC27.